Hi everyone, Krishna this side. So in this video, I'll be covering this Leetcode problem 2402 meeting rooms 3. They mark this problem as hard, but actually based on the constraints and the way we can solve this one, it is actually medium to hard level of problem. It's not basically hard problem. As usual, you can pause the screen and go through the problem statement. I'll directly explain you on the screen. Okay, these are the examples and these are the constraints. Okay, so now let us directly see on the screen. So here in the inputs we have given meetings array, okay, and another n value that is also given. So this n basically represents the rooms that are available with us, okay, and these rooms basically start from 0 and it goes all the way to n minus 1, okay. That is the information that is given to us, okay. And these meetings are basically representing the first meeting. Basically its start time and end time is this information is there. Second meeting start time and end time is given to us. Third meeting start time and time is given. So on, like this way, all the meetings that we are having, their start and end time is basically provided with us. So now what we have to do is we have to allocate these meetings in the available rooms. Okay, the rooms are basically starting from 0 all the way it goes to n minus 1. That is clear. So in these available rooms, if any room is available, we have to allocate these meetings. Okay, now if multiple rooms are available, we can simply allocate the room which is having smallest id. Okay, so let us suppose 0 is the id that is free, and then there is like a fourth room is also free. In that particular time, we have to allocate this any upcoming meeting in this 0th room, not in the fourth room. Okay, the smallest id that we have in that room only we have to allocate these rooms, allocate these meetings. Okay, now next is like at any point in time, if let us suppose there is a condition, right, like at a point in time all the rooms are occupied, no rooms are available, and any new coming meetings that we have, okay, that is something what we have to allocate. Now at that time point in time, if no rooms are available, what we have to do, we have to delay this meeting. Whatever the new meeting that we have to delay that meeting in a such a way that any room is available immediately. If any room is available next free room that we have in our bucket, in that time we can simply allocate this meeting. Okay, now at this particular time, since the meeting got delayed, we have to maintain the meetings duration. Okay, we have to make sure that whatever the duration that meeting is basically having, we will maintain it same, but it will start from the meetings whichever the room that we have, the free room that we got, from there that is basically started. Let us suppose room is basically available at 10, and the coming meeting that the meetings that we have is basically starting from 7 to 10. Okay, this is like 3 units of time it is taking, 3 units of time. And the free meeting that we got is at location 2. Okay, at location 2 we got the free at room 2 we got a free room. In there we will allocate this. So it is like its end time is 10, so from 10 we will simply push this meeting to 30. Okay, so now this room is basically available at 13. Okay, that is the idea. Okay, I guess the questions are pretty much clear. Question is pretty much clear. Now the next is like what we have to return in the output. We have to return the room number, okay, or room id which hold most meetings. Okay, which basically holds most meetings. If there are multiple rooms which holds most meetings, in that case smallest room id is something what we have to return in the output. Okay, I guess the question is pretty much clear to us. So the simple brute force approach that comes in our mind is like we have only 100 rooms in the constraint. If we notice right over here, right, only 100 rooms we have. Okay, and the meetings length is basically 10 to the power of 5. So all the way like meetings are around 10 to the power of 5, and this 100 rooms we have. So simply for each meeting, we will try to go through from 0th room till n minus 1, and we will try to see if room is available. At any point in time, if room is available, we will simply allocate this meeting. Okay, if no rooms are available, in that case we have to just make sure that which meeting is basically free earlier. That is something what we will try to maintain. And at any point in time, if earlier meeting is free, we got to know that let us suppose second meeting is available earliest, so we will simply allocate there. So it is like n cross whatever this n room numbers, n cross this meeting length. That is something called the complexity we get it, and it is acceptable as well, because this 10 to the power of 5 cross 100, if we do, it is like 10 to the power of 7, and that is basically acceptable answer. Okay, but in a case if this ranges goes, this n value goes from 100 to 10 to the power of 5, in that case it is like complexity goes like 10 to the power of 10. In that way, in at that point in time, this particular solution, whatever the approach that we are deciding, this brute force approach, that is not basically work. Okay, but for this one it works, so I'll explain you that approach quickly. I guess the idea is pretty much clear, like what we are trying to do. The first thing is like these meetings should be in a sorted order. Only then we will get to know like which is the new meeting that is having the smallest time. Okay, which is basically started at earliest. Okay, that is something what we have to make sure we are maintaining it. So data should be in a sorted order. Okay, and in this particular one, I already keep data in a sorted order, so we don't have to worry about it. But yes, that is something what we have to take care. N is basically equals to 4, so 4 rooms we have starting from the 0. Okay, this is like this is the information that we have starting from 0 all the way 3. Okay, 3 rooms. Initially all rooms are free. Initially all rooms are free. So yes, we can allocate the first meeting initially at the 0th location, because the smallest room ID that we have, if it is available, we have to keep that meeting in that particular room only. So yes, this first meeting we have allocated at this 0th location, 0th room. Okay, so now it's this room 0th room will be free at 13, because 13 is the time that it is being given. Okay, let me change the color. Instead of this one, I'll use this color. At the 13, this room is free now. Okay, and we will make sure we are considering a count array. Okay, this is a count array where we will keep on tracking the rooms, how many meetings basically each rooms considered so far. So initially in the count array of 0, the rooms is like it is basically one room it hold so far right now, and all the rooms are basically 0 so far. No meetings held in any of the rooms. Next is like first is been done. Now next is like 3 to 12. That is the time duration. So it is basically starting at 3. And this room basically 0th room is basically available at 13. We are again starting from 0th room, and so far we will keep on going, moving ahead which room is basically available earlier. There we are basically placing this room, right? Yes, at 0th location we cannot simply consider this meeting, because its start time is 3 and this room is available at 13. So at this first location we will see first location is actually available for us. Okay, so we can simply put this particular meeting. So its free time is now for first meeting is free time is 12, and this got updated with 1. Okay, the first room got updated with 1 because now it hold at least one meeting. Next is like 7 and 10. I cannot allocate it at this location because its free time is 13 now. Okay, simply we are maintaining a free time when this room is basically available, right? That is something what we are maintaining. So 7 cannot be I mean 7 start time is not actually equals to this 13, so we cannot consider. 12 is also not a great answer for us. This room is basically available second room, we can simply update right over here. Its end time is something what we have updated right over here, and again the count is also being incremented. Next is like 3 and the third room is basically available. We are basically checking for this particular last meeting. So this meeting is basically available after 13. This is available after 12. This is available at 10, and this is available so at 0, because it has I mean no meetings allocated so far. So yes, this meeting can be allocated right over here in this third room. Okay, so its end time is basically 12 now. Its end time is basically 12, correct? And count also got updated. Okay, count array also got updated. Now we are covered it with all these meetings so far till 8 and 12. Next is like 9 and 13. 9 and 13 is something what we got. So we will check this free time for this first room is 13. We cannot allocate right over here. Its free time is 12. We cannot allocate right over here. Its free time is 10. Okay. Now if the moment we see that again this sorry, this start time is 9, right? We cannot allocate simply right over here. Its free time is 12. Here also we cannot allocate this meeting. Okay, so we got to know that like at any location we cannot simply allocate this, so we have to delay this meeting. In that particular, if we are basically delaying this meeting, what we will do while going through this and checking, what we will do, we will track which meeting is basically having free time as early as possible. Okay, in that particular room we can allocate this one. Okay, right? So if we have 4 rooms with us and we saw that all the rooms are actually occupied, and this meeting basically starts basically at 9, but no rooms are available earlier, so we will simply go and check which is basically getting finished earlier. Okay, which room is basically free earlier, and in that particular meeting, in that particular room we can simply allocate this meeting. So simply while traversing only in the same for loop, we will try to maintain this. Okay, there is we can consider another value like earlier exist, earlier exit, earlier free, earlier exit, something like that. Which room is basically getting earlier exit, so room IDs also we will try to maintain right over here. So initially 0 and 13 is something what we have, so its exit is at 13 and its room ID is 0. So now at first location this room is basically available at 12. So this earlier exit was 13, so definitely this is better. So we can try to allocate this room at this first index. So this room ID is basically 1. That is something what we have traced so far. Now next is like 2 and 10. So yes, of course, this 10 is basically earlier exit. So yes, we can try to optimize this one. So this meeting can be allocated at this particular location as well. Yes, that is 10, and this room ID is basically 2. Correct. Next is like 3 and 12. That is the information that we have. So 12 is actually greater than this 10. Correct. So this is the best answer that we got it so far. Correct. Because 10 is the earlier time where this room is basically available for any coming meetings. Yes, we can simply consider this particular room index. So in the room index, we will simply update the count. So at the second, these are the indexes, right? So 0, 1, 2, 3, 4, 0, 1, 2, 3. So here the count got increased to 2, and the free time is basically 10. So 10 plus whatever this duration it is taking, 13 minus 9. Okay. So 14 is something what we will update right over here at this location. Okay. 14 is something what we update. Now its free time is like 14. Okay. So simply its free time is 14. It was 12 as usual earlier. Okay. Now this is done. Okay. And now simply we can reset this exit and room ID as well. Next is like 17 and 19 is something what we got. So for 17 and 19, it is like if we look here, its free time is 13. That means this room was available. Okay. Its start time is 17, and this room is basically available. This is also available. This is also available. This is also available. But the room which is available earlier, that is something what we have to consider as an answer. Okay. So the first room itself is available. So simply whatever is end time, okay, we will simply update right over here, and its count also we will increment. So this count basically got incremented to 2. Correct. I think simple steps. We are basically checking if room is actually available free, whatever the start time that is been given. If that is available, we simply update the room's free time, whatever the end time that is there, we will simply update it with free time. And yes, we are done. We will simply try to see next for the next meeting. At any point in time, if no rooms are available based on the start time, we'll try to maintain this earlier exit and the room ID. Whichever is the room that is free or available earlier, that is something what we will try to maintain based on the exit time. And there we will simply update that room. Okay, that meeting simply we can put it right over there. Okay, I guess this approach is pretty much clear. The complexity, if we consider, we are going all the way through this meeting. So if its length is m, and rooms are basically n, so m cross n is something about the complexity, we will get it. Okay. I hope this question this approach is pretty much clear to all of us. And yes, of course we can optimize this as well, because while going through, we are basically trying to see which is the smallest free time that we have with us, or which is the room that is if multiple rooms are available, which is the room that is actually having the smallest room ID. So simply it is like we are trying to maintain here also sorting. Okay. Which room is basically available earlier, which room is basically available based on the room ID. Okay. This both the information we are trying to maintain, if we try to notice right over here. So it is like kind of sorting the information whatever we are storing, it is in a form of sorted order. Okay. If that is the case, we can simply use the priority queue. Correct. We will try to see. Now simply let us say that this approach, I am not writing this particular piece of code, you can write it down. Now if the constraint got increased, definitely we have to think differently. Whatever the brute force approach that we tried, that is not going to help us. Okay. So same example I have taken right over here. I have created here a busy rooms priority queue. That is the first priority queue. It basically holds the room, which room ID is there we are at, and the time, end time. That means like when this room is basically available for us. Okay. If it is free, we can simply consider the meetings in that particular room. That is the information that this busy rooms basically hold. And there is another free rooms. This is also another priority queue. This is basically based on the I mean which room, based on the room's ID, it is basically sorted. So the room, free room basically, which is the smallest free room that is available, that is at the top. In that fashion we can maintain this information, this free rooms. Okay. This is another priority queue. Okay. Now what we will do is simply, in the initially all the rooms are free, so that is something what we will dump into the free rooms. Okay. Because all the rooms are free, right? So 0, 1, 2, 3. Okay. And this busy rooms, how we will sort it? Based on the end time. Okay. If any room's end time is if any room is finishing earlier, that is will be available at the top in the priority queue. If both the rooms have end time same, if there are multiple rooms whose end time is same, at that point in time, based on the room, we will sort the data. And this all the information is basically based on the ascending order, because whichever is the information at the top, that is something what we will pull it, and we will allocate this new meeting in that particular room, and we will again update the priority queue. It is something what, that is something what we are doing it. Okay. Yes, that is the idea. So why we are maintaining the two priority queue, that is also you will get it. Okay, with the examples, I'll when we start writing the code, we will get to know. Okay, we actually need to maintain here two priority queues. Two priority queues. That is something what we have to take care. So count array is something what I am maintaining, so that whichever the count is maximum, that is something what I'll consider as answer the room ID. These are the room IDs. At any point in time, if multiple rooms have same counts, in that case, whichever is the smallest answer so far that we got, that is the answer we will be having. Okay, so that we are maintaining a count array as well. I guess that is clear for us so far now. Now, initially all the rooms are free. So 0, 1, 2, 3, 4 rooms we have that is available in this free rooms priority queue. Okay. Now what happens? The first meeting comes. First meeting's start time is basically 2 and 13. So we will directly check that if there are any meetings that are free. If there are any meetings that are, sorry, if there are any rooms that are free. So 0th room is free, obviously at the top, which is the smallest ID, that is will be available at the top. We simply take this out from the priority queue. We'll put it right over here in this room. Room 0 is something what we have, and end time, basically its end time is 13. 13 is something what we have added it right over here in the busy rooms. Okay, now this is available. Now here comes an idea, okay, that I'll explain you further, like going ahead why we are actually maintaining two priority queues. Next is like 3 and 12. 3 and 12 is something what we have. We will check that if any room is available in the free room. Yes, of course there is like first room that is available, so we can simply allocate this meeting. So what we will do, 1 and 12 is something what we will put it into the priority queue. 1 and 12 is something what we will put because its end time is 12. So yes, based on that, we are adding it into the priority queue. So this is actually busy now. This room is actually busy. Okay. Now next is like this got taken out from this priority queue. Now this one is actually busy room that is available in the busy rooms area, busy rooms priority queue. Next is like 7 and 10. Okay, 7 and 10 is the information that we have. So its start time is 7 and end time is 10. Okay. So free rooms are basically 2 and 3. So whichever is the smallest, there we will allocate it. So it is like now in the priority data is basically in a sorted order. So here it is 2 and here it is 10. That is available because based on the end time we are sorting this data. So 2 and 10 is actually available at the top. 2 and 10 is actually available because it's priority itself maintain the sorting of this data, right? And whatever the logic that we have provided, based on that it sorts the data based on the end time we are sorting it. At any point in time, if end time is actually equals for the both rooms, so whichever is the smallest room ID, that will be available at the top. Okay, that is how we are doing this. Now that is done. Next is like 8 and 12. Okay, 8 and 12 is something what we have. Again, in a free room we have this 3 as an ID. Okay, so in that particular room we can allocate this particular information, so that will be available in the priority right over at this location. So it is like in the third room we have allocated, and its end time is 12 because it is 12. So 13 is actually I mean higher than this 12. So of course in the priority it will be put before this room 0. Okay, so this way this priority is actually full, and this free array is basically empty now. Next meeting is something what we got 9 and 13. Okay, so now no rooms, no free rooms are available. If no free rooms are available, whichever is the smallest end time, okay, which room is actually getting free earlier, that is something what we have to consider, and that is available at the top of this priority queue. Top of this priority queue, this information is actually available. Correct. Now I pull this information 2 and 10. Okay, I pull out this information from the priority queue because no free rooms are available, and we have to make sure that we will delay this particular meeting based on the room that is available as earliest. Okay, now this meeting got free at 10. This meeting got free at 10. Correct, and it is actually at the top. So that is something what we pull out, and this is basically taking 4 units of time. So 10 plus 4 is something what we will add right over here. It is like 14. This 2 and 14 is something what we right now update into the array. Okay, in the priority queue we will simply put this information 2 and 14. So this got pulled out 2 and 10, so it will get removed from the priority queue. Okay, and this 2 and 14 is something what we will add it into the priority queue, and it will be placed at the bottom of this priority queue because 14 is actually greater than the 13. So yes, of course it will be placed right at the bottom of this priority queue. Okay, I guess this should be clear. So far it is clear, right? So we are not having any rooms, any issues. Okay, now after this, new information that is coming is like 9 and 13. Okay, 9 and 13 is something what we got. So 9 is basically right over here at this location. 9 and 13 is something what we have. Its start time is 9. So in free rooms, no rooms are available right now. Okay. And if we notice this, it is start time is 9. So yes, before this 9, we don't have any rooms available. So whatever the top information that we have, that is something what we will pull out from this one. So it is like 1 and 12 is the top information that we have at the top, that is available, right? So 1 and 12. Okay, that is something what we pulled out, and it is taking 5 minutes of time. So in this 12 we will simply add 5. So it is like 17 is the answer that we got. So 1 and 12, 1 and 17 is something what we will update into busy rooms. 1 and 17 is something what we will update it. Okay, it is actually taking a lot of time to update it on the screen. Let me just take a quick pause and I'll be back. After this, there is an important concept, right? Like why we are maintaining these free rooms, right? So far, like once we got this, we are simply updating it into the busy rooms. At any point in time, we are not even bothering about the free rooms, right? Right? We are not considering like anything is there is nothing in the free rooms. But there is a point right over here. Let me try to see if it will update immediately. If not, I'll take a pause. Okay, it is not updating. Just let me take a pause. I'm back. So yes, again, now we are done so far. Like the counts, if we consider, right? So at 0, it is like 1. So one meeting we allocated so far. At the first location, we allocated 2 meetings. At second location, again here we allocated 2 meetings. Okay, and at third location we allocated so far 1 meeting. Okay, that was the whole idea. So far the counts also we will keep on updating right over there. So now this was actually got removed and it got placed at last index, because based on the this particular one, the first whatever the top element that we have, that is not we pulled out, and we updated it and we again put it into the busy rooms. Now the last information like 17 and 19. Okay, the meeting basically started at 17th time unit. Okay, and at the top it is like 3 and 12. 3 and 12 is something what we have. So it is like easily free, right? Because this meeting is actually free at 12 itself, and this meeting is basically starting at 12, 17. So yes, we normally as generally we are considering, we will what we will do is like basically at 3 we will update this last working time, that is 19, because from 17 it is started and this time is basically 12. So it is available. So from 17 and 19 this meeting can be taken place at this third room. So easily we can update this 3 and 19, and the count also we will increase this count. But here comes a problem. Okay, it says that if there are multiple free rooms available, if there are multiple free rooms available, whichever is the smallest one, that is something what we have to consider. We directly took the top element from the priority queue and we simply did that work. But if we notice here, all these rooms are basically available at this 17 time duration. All these rooms are basically available at this 17 time duration, and we just simply trying to pull out the top element and we have done that operation. But 0 is also there. If we at any point in time, if there is a smallest room available, we have to make sure that we will update into the smallest room. Whatever the meeting that has been there, we will actually consider it in the smallest room id, correct? So this is like at any point in time, if the top room that is there available in this priority queue, if we try to pull this out and we simply update it, it is not going to work. What we have to do, based on the start time, based on the start time, if it is actually greater than the rooms available in the busy rooms available, that means like those rooms are basically free till the 17, till the start time, all the most of the rooms are getting free. So what we have to do is, at any point in time, if rooms are this in the busy rooms, whatever the busy rooms that we have, if this start time, whatever the start time, if it is actually greater than this n times of these rooms, we will simply pull it out and we will put them into the free rooms. Okay, so initially 3 is actually getting pulled out from this room, then 0 is also, so 0 will be available at the top, then 2 is also because its end time is 14 and its start time is 17, right? So all these rooms basically we are taking pulling out from these busy rooms and we are putting it into the free room, so that at any point in time, if these rooms are basically not free, so this particular meeting can be allocated at the 0th location. That is clear, right? Because this room is free. So going ahead, this data is actually in a sorted order. So any information, then coming information that we are getting it, so based on the free rooms we can easily update them. Okay, so it is like pretty much clear. So at any point in time, if this start time basically in the free rooms, in the busy rooms, whatever the top information that we have, if it is actually greater than this n times in these busy rooms, those information we will keep on pulling it and we will put it into the free rooms. Initially, that is the first option that we will do if the busy room is actually not empty. Okay, so that way what happens is like whichever is the smallest information that we have, that will be available at the top in these free rooms, and we will be allocating this whatever this meeting that we are having, that we will allocate it at the free rooms. At any point in time, if the we are trying to pull out, but no data that is available in this busy rooms are actually uh, smaller or equals to this particular start time, then this all the rooms are busy, no free room is available. At that point in time only, whichever is the top data that we have, that is something what we will pull out, and this times difference, whatever the difference that we have, that is something what we will add it in this one, and we will update the count. Okay, that is how we will do it. So this count is basically, now 0 is basically free. Based on this information, all the rooms from this busy rooms are basically taken out from this busy rooms, correct? And this information basically got updated right over here. So 17 is basically what we can do is, at the 0th room we can allocate it, and its end time is 19. Okay, end time is 19, and basically this count also get increased. Okay, this count is basically 1. So yes, this way, if we start going from the start, so the zeroth meeting actually had hold 2 meetings, and rest also basically hold. Most answer that we got is like any room basically holding 2 meetings. Basically, all most of the rooms are holding. So the smallest answer is something what we have to return into the output. Okay, I hope the idea is pretty much clear now. So let us try to write down the code and see if there are any particularly challenges while writing the code. I think it is pretty much clear, right? So there shouldn't be any issue while writing the code as well. So this way, like, complexity get decreased. We are just running from the meetings area, and from the priority we are pulling the information, and we are just simply updating it. So of course the priority queue basically takes n log n, whatever the n value is that we are considering in the priority queue. So it will be better than the m cross n. If the length constraint is actually big, for this particular constraint, it should be fine. Whatever the brute force approach that we decided, n cross m, it should work fine. Okay, but yes, we will try to write the optimized code only. So first thing is, like, let us try to get how many meetings are there. M is something what I'll consider here. I don't think that we are required to get a meetings length. We can simply go through that. The first thing that I'll do is, like, I'll create here a count array, int count. Okay, new int, here its length is n. Basically, for each room, like, how many meetings basically what allocated, that is the information it will hold. And we will create here a priority queue, and inside this I'll maintain here int array, that is like the first priority queue, busy rooms. I'll name it as busy rooms. This will be like new. In this particular one, we have two conditions, right? So if we have, first is like a and b. From this one, the first condition is, at any point in time, let us suppose in the priority queue, how we are maintaining the data. At 0th index, room information is something what we are holding. At first index, we are holding the end time. That means the room when it is free, when it is available. Okay, at any point in time, if this end time room of 1, or if it is equals to second value that we have, at any point in time, if end times are matching, what we are returning, we are simply returning based on the start time. Sorry, it's not start time, based on the room id, based on the room that is, it is available at the 0 location, we are sorting the data. Else simply a of 1, that means, like, if they are not equal, so based on whichever is the smallest end time, that is what we are considering. I hope this priority queue is clear. Next priority queue is, like, basically we are just simply holding the free rooms. Okay, so in this one, simply an integer value is what we are holding, so it is like free rooms. Okay, free rooms, new priority queue. And by default it will sort the data in ascending order, so we don't have to provide here any query. Okay, I guess this should be clear. We have created all the information that we are basically trying to hold. We will simply try to go, first thing is, like, in the free array, these free rooms, we'll fill all the rooms, because initially at the starting point, every single room is free. So in the free, sorry, it is like free rooms dot offer add anything that we want to do. I'll simply consider add here, this I something what I'll add. So it will maintain the sorted order of the data 0, 1, 2, 3, whatever the n value has been there. N minus 1 information is actually available in this one, starting from 0. Now we will simply go through this meetings array. Okay, int meeting, from this where it should be, let me put right over here only, meetings. Okay, we will simply go through meetings array, starting from the first meeting. And of course this data should be sorted order, so I'll make sure to sort this data, array dot sort this meetings. Okay, and a and b, based on the start time, we will sort here a of 0 minus b of 0. Okay, that is what we are doing it based on the start time. We are I mean sorting this data. Okay, I guess this should be clear. The moment it is sorted, so top information is just based on the start time it is available. So start of the first meeting is something what I'll get it from here. Okay, meeting of 0, and end is also I'll get it from this one. So both the start and end time is something what we pulled out from this meeting. Now the moment we got the start and end time, what we have to do? We have to collect the time. Okay, total time it is taking total. Just let me name it as total only. End minus start, like this is like duration it is basically holding, and this will be required when we are actually dealing with meeting delay. Okay, if we are simply dealing this meeting, we'll try to add this total time in the meeting in the room which is actually earliest. If it is earliest finishing meeting, there we will add this one. Okay, based on the time. Now this information is something what I have retrieved. The next thing is like we will check that. The first thing is like we will run a while loop. In this while loop, if any, this first thing is like this busy room shouldn't be empty. Busy room is, if it is not empty, okay, here we will check if this start time, whatever the start time that is there, if it is actually, if it is actually greater than or equals to, okay, busy rooms, busy rooms, whichever is the peak element that we have in the peak element also, peak of, peak of 0, because peak of, sorry, 1, whatever the end time that we have, if end time, whatever the room that we have in these rooms, busy rooms, if its end time is actually less than or equals to the start time, okay, that means like start time is actually greater than or equals to this busy rooms end time, that means that is something what we have to pull it, and we have to put it into the free rooms. Okay, so simply in the free rooms initially this while loop won't run because the busy rooms is not empty. Sorry, it is actually empty, so at the first loop it won't be having any value, so this won't run at all. Okay, in the free rooms what we have to do, we have to add or offer this busy rooms. Okay, busy rooms dot pool, we will simply pull it, and the first the zeroth index, the room's id is something what we will add it into the free room. Okay, I think that should be clear, and this will keep on running until all the rooms are actually available. I mean, we pull out all the free rooms that will be available before the start time or equals to the start time, so that the data in the free rooms are basically sorted order. So we'll check that if now in the, if the free room, whatever the free room, if free rooms dot is empty, if it is not empty, so let me put here not, if it is not empty, whatever the top element that is there from the free room, okay, we will pull it out. So int room from this free rooms dot pull, because rooms information is something what this basically holding, so top information we pull out, and this we will allocate it into the busy rooms. Okay, this meeting we will allocate it into this room, so busy rooms that offer this room. So how we can do it? New int, first is like room and the end time. Based on the end time, we are updating this information. It is not end time, it is end. Okay. So yes, that is something what we have. So if at any point in time, if no rooms are available, that means like all rooms are busy based on the start time. Like the start time is so early that no rooms are actually available. So we have to make sure that whichever is the top element in this busy room, okay, that is actually available as early as possible, right? So we will simply pull it. Okay, we will simply pull that information. Let us suppose int top data. Okay, that is the top room that we have. So from this top data, what we are doing, we are getting a room id. Okay, so again we will simply add this busy rooms dot add or offer whatever the pool we have done from this top data. Top data of 0 is the same, in the same room we are again adding this new information. How we are adding it? We are getting this top data of end time, basically that is available at the first index, plus what we are doing, this meetings start time minus end time, that is something what we have retrieved it. So totally something what I'll add right over here. I hope this is clear. Okay, so if no rooms are available, we trying to get free rooms if there are any free rooms available based on the start time, but we didn't get any rooms. If no rooms are available, that means whichever is the top element that we have, that is something what we pull out from the priority queue, and in that top rooms end time we will simply add the total. So total duration that this meeting basically takes, because don't want to we don't want to basically in the statement we have read it, right, like we don't want to reduce the timing. Okay, whatever it is taking the time, that is something what we have to maintain. The same duration is something what we have to maintain. So meeting basically started from this top data, whatever the end time that is there from that time. So the total duration is something what we will get it from this total. So we will simply add it so that the meeting got delayed. Okay, and based on that we got answer. Okay, this way we have maintained this one. While maintaining this, the count is also something what we have to maintain. So in the count array, the count of this room, we will simply update it. Right over here also in the else condition, count of this top data of 0, top data of 0, we will simply update its count. Okay, because it's in the top information, whatever the top value that is available in the busy rooms. Okay, there we actually added this again, right? So yes, so priority queue will keep on maintaining its consistency right over there. So whichever data needs to be sorted, it will keep on sorting the data based on the logic that we have provided. Now once it is done, what is the answer that we have to return? We have to return the max answer, right? So int answer equals to initially 0. We'll start from this count array, I equals to 0, I less than n. Okay, I plus plus. In this one we will check that if currently, let us try to consider a max also. Int max equals to 0. At any point in time, if count of I, if it is actually greater than this max, whatever the max value that we have, we will simply update the answer with this current index. Okay, because that is the meeting ID that we have. The moment it is done, we will simply return the answer. Okay, I hope this should be clear, whatever we have done at the last as well. So we have simply a count array. In the count array, if at any point in time, if there is a maximum answer that we are getting, that is something we have to consider. Line number 9, we have errors. Okay, if a and b. Okay, let me see what I have done wrong here. Here it is end, so a should be like int array. So why it is saying wrong? It's not a statement, right? So if, okay, I haven't put here if, right? So if that is not, it missed. If a of 1 equals to b of 1. Also again right here we have to return this. Okay, I think this should be fine now. Let's see if it is working fine. Okay, we have errors. Line number 36, busy rooms. Okay, dot add cannot be applied, this int. So yes, new int, this needs to be converted into the array, right? I cannot simply pass this statement. That statement is not a valid statement. Okay, we converted it and we have added the information. Now we have an error. Okay, so what is this error? Its output is 0 basically, and for the second one, what is the expected answer? 1 is the answer that is expected. Let's try to see where we went wrong. I think we initially added all the free rooms, and here it is like at the 0th location is the room, and this end time is something what we have considered. So if both the end times are basically equals, we are sorting it based on the room ID at any point in time. If not, so whichever is the smallest end time that is there, we have put there. The priority is we have created free rooms. In the free rooms we have added all the rooms IDs. Now we are going through these meetings. Okay, the first meetings we got it here. Here it should be 1, right? So end time, I guess that should be an error. End time is something what we calculated wrong. The moment that start and end time we calculated total time. Okay, so that we can easily add it if there is no point where we can allocate the meeting in any free rooms. So whichever is the earlier free rooms that we are getting, we simply add it. We are checking here if busy rooms is not empty, and the start, whatever the start time is actually written this busy rooms peak, whichever is the peak element that we are pulling it, and we are checking the end time of that top element that is there. If so, we will simply add this by pulling this information from this one, and 0th, whichever is the room that is there, we will simply add this right over here in this particular free rooms. If free rooms is not empty, we are again pulling the information from the free rooms, we are adding it into this one, the end time, and we are incrementing the counter. Same goes here. If no free rooms are available, which is the top element that is there, we simply pull that information in top data 0, whatever is the top data 0, that is room is something what we put it into the busy rooms, and top data of 1 plus this total information is, that is something what we added, and counter is also we incremented. I guess the rest is fine. Let me try to run the code. Both the answers are getting wrong now. Okay, I didn't expect this one. Now we started from the 0th index. Okay, we started from the 0th index, we go all the way to n, and count of y, if it is actually greater than the max, max is also we have to update it, right? So yes, that is something what we have to do. That's why I have maintained the for loop, but usually I use math.max and we are just relying on that. But answer is something what we have to update. Both the answers are getting right. So let us try to submit this code. Yes, it should work fine, I guess. Yeah, it is getting accepted. Now, talking about the complexity, here this priority queue basically always takes, we are maintaining all the rooms, right? Meetings, sorry, we are maintaining based on the meetings. This information is basically getting maintained. So if there are n rooms, n meetings, we are basically hold at n point in time. So n cross n is the priority queue that we, this value that we get. And this sorting is like m cross m. So m cross m plus n cross n, that is the value that we get it, okay, from the time complexity. And storage, obviously, like we are storing this n data in this busy room as well as this free rooms, like n information is something what we are storing data over here. And this for loop is basically run at once, right? Like whatever the meetings, m meetings we have, and we are sorting it this in the free rooms and this one. So it is like obviously whatever the sorting that time complexity that I told right over here, that basically gets applied right over here. Okay, so it is like n plus n log n plus m log n. That is the complexity that we get it, and I think it should be fine, right? Yes, that's all from this particular video. If you get the idea, thank you for watching this one. Bye bye.